With companies like Volvo increasing configuration variants and complexities across their catalog of products, concurrent engineering and manufacturing is critical. Volvo needed to accelerate time to industrialization by propagating design changes from engineering to the shop floor in a quick and efficient manner. Enabling a free flow of information between engineering and manufacturing is critical for designing improved components and bringing them to production quickly. PTC's Windchill PLM enables this efficient, accurate, and traceable workflow for product development while reducing time to market, lowering costs, and improving quality. Leveraging Creo's generative design capabilities, a new cooling fan was developed and incorporated into a configurable E-bomb. Replacing a number of different designs, this new generatively designed fan is lighter, stronger, and compatible with every engine variant, reducing supply chain complexity and increasing reliability. Through Windchill's change orchestration process, the affected suppliers are notified of the update through their ERP systems. At Volvo, a change task is automatically sent to the manufacturing engineer responsible for this part of the Mac engine assembly process. Opening the visualized M-bomb and E-bomb side by side, the engineer consumes the changes from the E-bomb into their downstream manufacturing planning deliverables. By selecting View Equivalent Occurrence Status, the engineer can see the modifications in the E-bomb. With control characteristics and parts added, the engineer can save the changes, propagate them to the M-bomb, and then begin updating the assembly process for the engine. Opening the assembly, the engineer can see the visualized M-bomb with the added parts highlighted and the process plan with the full assembly. With playback functionality, they can review step by step how the engine is assembled to decide where and when to add the new components. By selecting Insert Operations, the new operation is added to the process plan assembly and can provide sub-operations to address complexity. To make sure the cooling fan is installed in the ideal manner, the engineer leverages PTC partner Industrial Path Solutions to simulate exactly how the part is to be assembled. By testing and simulating the ergonomics within the assembly line fixture, the manufacturing engineer can make further changes to the M-bomb, updating and defining the process plan for assembling the engine. With all the characteristics, CAD models, work center for the operator, and assembly tools added to the process plan, the engineer can review the playback with the added cooling fan included in the assembly. Work instructions are now ready for deployment, fully illustrated with links to all parts, assets, and control characteristics listed. After fully assembled, quality inspectors leverage augmented reality to compare the as-designed to the as-manufactured engine, catching errors before they leave the factory. Windchill further provides closed-loop quality through MPM and ThingWorx. If an operator conducts a quality check and finds an issue with the assembly, they can easily generate a problem report for engineering to correct the issue. With a task in Windchill noting that the connected tool fails to adhere to the required torque setting, manufacturing engineers can update the required torque in the process plan and push the change directly to the work instructions, ensuring operators continue to have viable information. By connecting upstream and downstream stakeholders from design all the way to the shop floor, Windchill provides the backbone for an industrialized digital thread. With a cohesive and effective transfer of information, Windchill accelerates time to market, improving both cross-team efficiency and quality.